Okay, welcome to lesson 7 video. We're going to do a little bit different format this time, and we'll try it and see how it goes. So this diagram represents the figure in the textbook on page 68, numbers 2 through 9. So numbers 2 through 9. And in those problems, you are asked to name some figures on the drawing, such as, let's see, number 2 talked about name 3 chords. What are 3 chords that you see on here? Well, a chord is a line segment with endpoints on the circle, such as AB, BD, and what else? DF, and that's 3. So number 3, name 1 diameter. Well, a diameter is a chord whose center passes through. Diameter is a chord that passes through the center of the circle, such as EC. And number 4, name 5 radii. Well, we got PA, PB, PC, PE, PF. Are all radii. And then the 5th one is name 5 minor arcs. Minor arc is something like this right here. That would be a minor arc. Arc is a part of a circle, and a minor arc is less than half of a circle. So AB would be 1, and BC would be another one. AE would be 1, EF, and FD. Okay, number 6. Name 2 semicircles. That's half of a circle, so we could do EBC. That would be half of a circle. Does it matter if you go EAC or EBC? No, same arc. What about EFC? Okay, that's the bottom half of the circle here. So if we do 2 minor arcs, let's do EBC as the top. It's top, not minor arc, top semicircle, and the bottom semicircle would be E. Let's do FC. And so those are 2 semicircles. Number 7, name 2 major arcs. So that's just more than half of a circle, such as EDB. That whole arc, that could be one. So EDB, it's a major arc. What about FCA? See, if I want to do an arc from F to A, that big arc there, I just pick one random point along it. I could do FCA, FDA, FBA, either one would work. So FCA, arc FCA, and there we go. Next is 8. Name 2 tangents. Tangent is a line that intersects a circle at one point. So we have HB and FG, looks like. And finally, number 9, name 2 points of tangency. Those are points where the tangent intersects the circle, which is B and F. Okay, and that concludes 2 through 9. Next we'll go on to 11. For that I'll move back to some blank paper here. Okay, so line it out here. We'll do number 11. And in the textbook it has a picture of a circle, which I'll just draw with this here. and the center is O, and then I'll estimate 110 degree angle. P, Q, and then this is the point R right here. And then it said, okay, what's the measure of arc PQ equal to, and what's the measure of arc PRQ equal to? Well, this measure of this arc is the same as the measure of its central angle, so this is going to be 110 degrees. So 110 degrees. The measure of that major arc, PRQ, is basically the reflex measure of this angle. The reflex measure is if you measure it from here to here. What's that measure of that angle? Well, if the whole thing is 360, then this would be 360 minus 110, which would be 250 degrees. So that means this whole major arc is 250 degrees, and that's number 11. In 12, then, it says to use your compass and protractor to make an arc that measures 65 degrees. So this is the compass that, well, there's two compasses that all you guys will use. This is the one that I had you purchase, which is good for doing constructions in chapter 3, but you'll notice that when you try to use it to make circles, it's not always so stable. So this one, which I have in class, is good if you just want to make a circle. And I'll go ahead and there's my circle. Got the center point. Let's see here. So 65 degrees. So that's going to involve. So I'll start with the radii here. And I'll use that radii as the basis with which to measure 65 degrees from the 0 mark. 65 is right here. So 0, 10, 20, 30, 40, 50, 65. Dot it up. And then connect the center to that point. That's 65 degree angle. And so we'll just call this AB. So that arc then will also measure 65 degrees. And now I want to make an arc that measures 215 degrees. So to do that, let's think about it. Well, half of a circle is 180 degrees. So if I take 215, subtract 180, I'm left with 35 degrees. So what I really want is half of a circle plus an additional 35 degrees to get that 215 degree arc. So again, I'll line it up here. So the center's at the center of the circle there, and measure out 35 degrees right there. This is 35 degrees, and I'll just call that C, D, center O. Okay, so this whole arc, so the measure of arc, we'll call it CBA, is 215 degrees, pardon me. 215 degrees. Is there anything else? Maybe we'll each arc with its measure, so just make this 35 degrees, and then this one would be, let's see here, it's 180 minus 65, 115 degrees. Okay, so I labeled it. Yeah, and the arc measure goes out here, and the angle measure is right here. So there's 12. Okay. Next is 16. And let's see, it says sketch circle P and sketch a circumscribed rectangle about circle P and sketch a rectangle inscribed in circle P. What do you notice and what do you think this is true for all rectangles? Okay, it says to sketch. I'm going to use a compass here, it just looks a lot better. So there's my circle. We'll call it circle P, and then it says to sketch a circumscribed rectangle about circle P, and I do sometimes forget which is which, so let's see if I can. So it says circumscribed rectangle, circumscribed quadrilateral means it's outside. Look at that. Circumscribed quadrilateral. So circumscribed rectangle would be outside versus an inscribed. So inscribed rectangle would be inside here, but circumscribed rectangle is going to be outside. So I'll go ahead and do my best. It's a sketch, so just kind of try to make approximate 90-degree angles here. Okay. Alright, those are about right angles. So that's my rectangle. Okay. Sketch a rectangle inscribed in circle P. And so let's inscribe, so I'll just do the same thing. Okay, and the question is, what do you notice? Do you think this is true for all rectangles? So what do we notice about these two shapes? What do we notice? Well, it looks to me that this rectangle, and I'll just real quick here, looks to me that this rectangle on the outside is a square. So it looks to me that circumscribed rectangle is a square, whereas the inscribed one looks like a rectangle. And it turns out this is true for all circumscribed rectangles or squares. Okay, and finally we have 17. Use your compass to construct two circles with the same radius intersecting at 2 points and label the centers P and Q. Okay, so A couple ways. If you're using this compass here, you would just set it to the same setting and do 2 circles. Have the same radius, so I'll go ahead and do that here. And just set it somewhere else. Intersects at 2 points. I think we'll actually redo that so I can get a better point a little bit further away. There we go. So those are the 2 points where they intersect at. I'll go ahead and finish the circle here. There we go. Okay. Alright, so 2 points. Label the centers P and Q. And label the points of intersections A and B. Construct quadrilateral PAQB. And what type of quadrilateral is it? Well, this is a radius, this is a radius, this is a radius, this is a radius. They all have the same radii. So we have a rhombus. All right. Well, that concludes the 1.7 homework. Thank you for listening.